Hello everyone, hope you're all doing good. So friends, today let's learn how to find out trigonometric ratio of compound angles using the concept of triangles. So today we will see how to find out cos of a plus b. Now for that, let's consider this circle which is having radius 1 unit. Okay, now this is the center of the circle. Now we are going to place the x-axis and y-axis in such a way that the origin is exactly coinciding with the center of the circle. Okay friends, over here. Now since the radius is 1 unit, what will be the coordinates of this point L? Yes, it will be 1, 0. So the x coordinate will be 1 because the radius is 1 and the y coordinate will be 0. Now let's consider any point P on this circle. Okay, this point P. Now let's join the origin with this point P. Now can you tell me what will be the length of OP? Yes, it will be again 1 unit because the radius is 1. Now let this point P make an angle A with the positive side of the x-axis, friends. So we are going to measure in the anti-clockwise direction, so it will be plus A. Okay, again let's consider another point Q which is a little further up here. Now again, if I join OQ, this distance will be 1 unit and it makes an angle B with OP. Now again it's in the anti-clockwise direction, so it will be plus B. Now let's also take another point, say we'll call it as R. Now this point R, again OR will be 1, but it makes an angle again B, friends. Okay, it makes an angle B with the positive side of the x-axis. Now because it's making an angle with the x-axis positive side, we have to measure in the clockwise direction, friends. See, it have to measure here. So because we are measuring in the clockwise direction, B will get a negative sign. Okay, anti-clockwise is positive, clockwise means negative. Okay, now is it possible for us to find the coordinates of these points of P, Q and R just by knowing the angle that they make and this distance? Yes, definitely we can find it. How? Let's see. So for that, let's first take this coordinate axis again. Okay, now here is my x-axis and y-axis. Now I have a point P over here, friends. Okay, now it is at a distance of R units and it's making an angle of theta with the positive side of the x-axis. Okay, now we can always drop a perpendicular from point P on the x-axis like this. So since it's a perpendicular, this angle will be 90 degree. I'll call it as Q. So this triangle POQ is a right angle triangle, which means I can definitely use, yes, trigonometric ratios. So let's find out what will be sine theta. So sine theta will be the opposite divided by hypotenuse, OP by, yes, it will be PQ by OP. Okay, so sine theta is equal to PQ by OP is R. So what is PQ? Yes, R sine theta. Now again, what will be cos theta? Cos theta will be adjacent, that is OQ by OP. So cos theta will be OQ by R. So OQ will be R cos theta. Now what is this length PQ? Did you see this? PQ is nothing but the distance of this point P from the x-axis. And what is that known as? Yes, it's the y coordinate. So I can say that the y coordinate is PQ, which is R sine theta. Friends, in the same way, look at OQ. What is OQ? It is the distance of this point P from the y-axis. So it is the x coordinate. Yes, so very nicely we have got the x coordinate to be R cos theta, y coordinate as R sine theta. So if I apply the same logic over here, friends, see, the same logic here, only thing is the distance of the point P, Q and R from this origin is going to be 1. Okay, the angles are different. Okay, so if I see for point P, what is it? Yes, the distance is 1 and the angle is A. So what will be R cos theta? 1 into cos A, that is cos A. See, I've already got the x coordinate. What will be the y coordinate? Yes, it will be R sine theta, that is 1 sine A. Okay, so that will be the coordinate of P. Let's find for Q also. Now Q is making an angle of not just B but A plus B with the positive side of the x-axis, right? So it will be cos of A plus B, yes, and sine of A plus B. Friends, in the same way, let's see for R also. It will be cos of, now this angle over here, I'm measuring in the clockwise direction. It will be cos of minus B. Remember, not just B. This will be sine of minus B. I hope the difference you got it. Now, cos of minus B is nothing but cos B. Yes, we have learnt it. Sine of minus B is minus sine B. Okay, so now we have got the coordinates of all these 3 points. Now what we will do, friends, is let's just join PR and let me also join QL. Okay, now we can do this further thing in 2 ways, friends. I'll tell you both the ways. Let's first do it using triangles. So just consider triangle QOL and triangle POR. Okay, QOL and POR. Now let's try to prove that these 2 triangles are congruent to each other. So for that, I need to show 3 criteria are equal. Now friends, did you notice OQ over here is equal to OP in this triangle? Why? Because it's the radius. In the same way, look at OL over here. OL is equal to OR, which is again 1 unit. Now let's consider this angle QOL. Okay, now what is QOL, friends? What is this angle? Yes, it is A plus B. Similarly, what is angle POR? Okay, now POR is a little bit problem, friends. Is it going to be A minus B? Let's see. Now we are measuring A in the anti-clockwise and B in the clockwise. So we really can't find out the value properly. So let's consider measuring it in the same direction, either clockwise like this or anti-clockwise. So because we are measuring everything in the anti-clockwise, let's proceed with anti-clockwise only. This way, friends. See, so it will be minus of minus B. Did you get this? Yes, I'll write it properly. Minus of minus B, because I'm going in the anti-clockwise direction, but this is clockwise. Okay, so it will be minus of minus B plus A. This is very important, friends, to understand why it is minus of minus B. Okay, so minus of minus B is plus B. So what is this? Angle QOL is equal to angle POR, right? Yes, so by SAS criteria, triangle QOL is congruent to triangle POR. Yes, that's very nice. Now, friends, by CPCT, you have already learned, yes, corresponding parts of congruent triangles. So by CPCT, I can say that this QL over here is equal to PR. Yes. Now friends, if you don't want to use congruency, you can also use circle theorem. Now, we have seen that this QOL is equal to angle POR. Now, in circle theorem, we have a theorem that says that chords which subtend equal angles at the center are also equal. Now, look at chord QL. It is subtending this angle at the center. Look at PR. That is also subtending this angle POR at the center. So again, I can say that angle QOL is equal to angle POR. So the chords which are subtending these angles will also be equal. So by circle theorem, I can again say the same thing. Okay. So by both the methods, we have shown that QL is equal to PR. Now, what is QL, friends? We know their coordinates. So let's find the distance formula. Do you recall the distance formula over here? See, distance is square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Okay, where these are the coordinates. So let's substitute. So QL is going to be square root of cos of a plus b minus 1 the whole square plus sine of a plus b minus 0 the whole square. Now that is equal to PR. What is PR? Yes, cos of A minus cos B the whole square plus sin A minus sin B the whole square. Okay friends, so let me keep this over here. Now why do we need square root, right? So let's just square on both the sides. So we'll get cos of A plus B. I'll just copy it without the square root. So friends, did you see the mistake that I've done? It's sin A minus of minus sin B. So it should be plus sin B. So please don't make this mistake. So it will be sin A plus sin B the whole square. Okay, so let's use the identities A minus B and A plus B the whole square. So here I'll get cos square A plus B plus 1 minus 2 cos of A plus B. Now this will be plus sine square A plus B over here. On the RHS, let me see. I will get cos square A plus cos square B minus 2 cos A cos B plus expansion of this plus 2 sin A sin B. Wow, that's great. Now friends, let's look for some simplification. So cos square and sin square. What is the trigonometric identity? Yes, cos square theta plus sin square theta is 1. So cos square A plus sin square A, this will also be 1. So I'll get 1 plus 1 minus 2 cos of A plus B is equal to, again here friends, cos square A, sin square A is 1. Sin square B plus cos square B is 1. Other things I'll copy as it is. Well, definitely 1, 1, everything will get cancelled. Now here I have, everywhere I also have a 2. Did you notice that? So let me take that out common. Okay. Look at this friends, at least we are now coming very close to our answer. But this cos of A plus B is having a negative sign. So let me just multiply by negative sign throughout. Yes. Wow, did you see this? We have got the formula for cos of A plus B using the concept of triangles, friends. It's very easy. Okay, I hope you understood. So friends, if you found this video useful, do like and share. Consider subscribing to Enjoy Math. Please do leave your comments and feedback in the comment section below. So till we meet again, take care.